Hi, now I am going to explain Newton's interpolation with Python. Here I am going to explain a Python code written to solve a problem using Newton's forward and backward interpolation. Here we can see how the formula is using in the code and how it is working on a problem. I have some data here. In this data, the temperature is recorded at different times and the values are presented in a table. Now I have to estimate the temperature at 11 a.m. and at 3 p.m. See, the temperature at 11 a.m. and at 3 p.m. are not available in the table. I can estimate these values by using Newton forward and backward interpolations. To solve this problem, I will write simple Python code. Now I will explain how to write each and every step of the method in Python code. First, I have to generate difference table by using given values. To generate difference table, I am taking x values in first column, y values in second column. Here x means time. I am taking time as x. I am writing time in first column. And temperature is y. I am writing temperature in second column. See the differences. 18 minus 15, that is 3. 24 minus 18, it is 6. 22 minus 24, minus 2. 21 minus 22, minus 1. Next, 6 minus 3, 3. Minus 2 minus 6, minus 8. Minus 1, minus of minus 2, that is plus 1. Minus 8 minus 3, minus 11. 1 minus of minus 8, 9. Finally, 9 minus of minus 11, it is 20. I have to generate this difference table in my Python code. For that, in Python code, I write this difference table in convenient form. You can see two difference tables here, one for forward interpolation and second one for backward interpolation. You have to observe one thing, I am not using x values in forward and backward difference table because x values are not necessary. In forward difference table, I start differences from first row. In backward difference table, I start differences from last row. See, I'm not changing the original difference table, just I'm writing all differences in convenient form. This is more convenient to substitute in the formula if you write in this way. You have to observe one thing in forward difference table. See, I'm writing all these differences in first row. Next, I am writing these differences in second row and these differences in third row. Finally, this one in fourth row. This is forward difference table. When we come to the backward difference table, you can see we start differences from last row. See, in last row, I am writing these differences. Means last row means here that is the fifth row. In fourth row, I write all these differences. In third row, I write all these differences. Finally, I write this one in second row. This is for backward difference table. If I generate separate tables for backward and forward, it will be more convenient to substitute in the formula. Now I write Python code. First, I import the library numpy as n. I generate first array with the values of time and I am saving this array with the name x values. And the second array is generated with the values of temperature and I am saving this second array with the name y value. To generate difference table, I need number of y values. See here, I am using the function len to find the length of y values. I am saving the result with n. You can also verify that by using print n. If you run the code, you will get here n equal to 5. So number of y values are 5. To generate the difference table, first I'm initiating one table with all zeros. Using NumPy library, I'm generating a table with 5 rows and 5 columns with all zeros. And I'm saving the table with the name difference table. Once you can verify the table using print function, print of difference table, you can see output like this. Next, I replace all these zeros with differences. First, I will generate forward difference table. To generate forward difference table, I define a function here. You can see here def means I define a function with the name forward difference. These are the steps I need to generate forward difference table. Now I will explain each and every line in this part. First, I have to define a function with suitable name. See, here I am going to generate one forward difference table. So I am writing function name as forward difference. Under this function, I write few steps which are used to generate forward difference table. In my calculation, I am using only y values. So in this function, I have written here, you can verify here. I have written only one variable y because in all this calculation, I am writing only y values. First, I need length of y means number of y values. I am saving the number of y values with n. Next, already we discussed how to initiate the difference table. I need to generate one n cross n rows, n columns table with all zeros. So you can see here np dot zeros. We can observe np dot zeros n comma n. This generates a table with n rows and n columns. Here n equal to 5 with all zeros. And I am saving this one with difference table with the name of difference table. Whenever I need this table, I can call this table with its name difference. Now in the difference table, I have to replace the first column with y values. Once you look at this difference table in this line, you can see here this 0 indicates the first column of the table. See, I am replacing this first column with y values. You can also observe the resulting table. After replacing y values, the new table will be like this. Now I fill the difference table with differences. For this, I use for loop on column. You can see here, I have written one for loop on columns. For j in range 1 comma n, here j takes 1 comma 2 comma 3 comma 4. Here n means length of y, number of y values. Number of y values are 5. So j takes 1, 2, 3, 4. Here 1 means second column. Already you know in Python index starts from 0. So j equal to 1 means it is a second column. J equal to 2 means it is a third column. J equal to 3 means it is a fourth column. J equal to 4 means it is a fifth. Inside this for loop, I have written another for loop on rows. You can see the second for loop for I in range n minus j. Here I value starts from 0. To find the differences, always we subtract a number from the next number in the corresponding column. See, in this table, we subtract 15 from 18, next 18 from 24, next 24 from 22, next 22 from 21. So every time we subtract a number from the next number in that corresponding column. I have written the same thing in the third row of the code. See how to write the formula. First, I will show. 18 minus 15. First difference is 18 minus 15. 18 that lies in second row, first column. Second row, first column. Second row index is 1, first column index is 0. Okay. So from second row, first column, we are subtracting 15. 15 lies in first row, first column. Once you can observe this. 18 means what is the position of 18? Second row, first column. Second row means its index 1, first column means index 0. 1, 0. This indicates second row element. Next, we are subtracting 15 from 18. So 15 means here it is a first row, first column element. So the index is 0, comma 0. Now you have to save this value in first row, second column. You can see we are saving the value is 3. We are saving that value in first row, second column. First row, second column means index is 0, 1. The 0 indicates first row and 1 indicates second column. See, this is applicable for all the differences. So we are writing one general formula to find all the differences in third row. You can observe the third row. We are writing the general formula to find all such differences. Now we will see how the for loop is working. In the first for loop, j equals to 1. J equal to 1 means it is a second column. We are starting with second column. See, on right side you can observe that j equal to 1 means it is a second column. Then we can go for the second for loop. In second for loop, I equal to 0. I equal to 0 means it is a first row. Second for loop depend on rows. So here I equal to 0 means first row. Next, then we can go for the third line. See, we have to calculate the differences. Okay, we have to put I equal to 0 and j equal to 1. So what is the result here? Difference in difference table 0, 1. 0, 1 means first row, second column element. Okay, on left side, see, we have to save the result in first row, second column. Okay, what is the difference here? You can see, you can observe that. If you put I equal to 0 and j equal to 1 in difference table 1, 0. 1, 0 means second row, first column element minus 0, 0. Difference table 0, 0 means first row, first column means it is 18 minus 15, that is 3. You have to save this 3 in first row, second column, that is 0, 1 index. I think it is clear. After this step, the resulting table is this one. You can see resulting table like this. This is the resulting table. After calculating the difference at I equal to 0, now I takes 1. Here I equal to 1 means it is a second row. We calculate the difference in that second row. Now we put I equal to 1 and j equal to 1 in the third line of the code. That calculate the next difference. You can observe the right hand side here. Once you can see here, we are finding the next difference. Already you know the next difference is 24 minus 18. See, we are getting the same thing when we put I equal to 1 and j equal to 1. See, 2, 0 element. 2, 0 element means third row, first column element minus 1, 0. 1, 0 means second row, first column. So 24 minus 18, that is 6. We are saving that 6 in second row, second column. You can observe here. We are saving that 6 in second row, second column. This is the resulting table after this calculation. Now I takes 2 means it is a third row. Once look at this, we are calculating the next difference. It is 22 minus 24. Okay, 22. What is the position of the 22? It is in fourth row, first column minus 24. 24 means it is in third row, first column. So you can see the index 30 and 2 0. Okay, after this subtraction, we have to save the result in third row, second column. So index is 2 comma 1. After this calculation, you can see the resulting table. It will be like this. Now I takes 3 means it is a fourth row. We are finding the difference in fourth row. Once look at this. What is the difference? 21 minus 22. 21 minus 22. Once look at this. When we put I equal to 3 and j equal to 1, you can see 40. 40 means we can observe this one. 40 means fifth row first column. Fifth row first column means it is a 21. Next 30. 30 means fourth row first column. It is 22. So 21 minus 22. Now we have to save the result in what is that position here? This is fourth row second column. Fourth row second column means index is 3 comma 1. So we have to save the result in 3 comma 1 position. With this, all calculations are completed in first column. Okay, you have to observe one more thing here. See, j starts from 0 to n minus j. Here n minus j, n equal to 5, j equals to 1. Total it is 4. Now you can see, means here I takes 0 comma 1 comma 2 comma 3. Now you can see for inner for loop already it is completed. I equal to 0, I equal to 1, I equal to 2 and I equal to 3. Okay, inner for loop is completed. And you can also observe the table. The second column is filled with differences. Now we can go for the third column. Third column means we have to come to the outer for loop. Here j takes 2. Now j takes 2. You can look at this. J value is 2. Means we have to fill third column with differences. Then we can go for inner for loop. And in this inner for loop, I starts with 0. 0 indicates it is a first row. Now I have to fill this position. See, this position means it is in third column, first row. Third column, first row. See, what is j value? It is 2, means third column. What is I value? It is 0, means it is a first row. To find this difference in formula, I have to put I equal to 0 and j equal to 2. See, with this substitution, you can observe here I equal to 0, j equal to 2 means it is 1 1. Index is 1 1. 1 1 means second row, second column element. Second row, second column. Second row, second column means you can observe here in the table second row, second column. It is a 6. Okay. Next, minus index is 0 comma 1. 0 comma 1 means first row, second column. See, first row, second column. Look at in the table. It is 3. So 6 minus 3. The result is 3. Now we have to save this result with index 0 comma 2. 0 comma 2 means first row, third column. See, we are saving that result in first row, third column. Now I have to fill this position. See, what is this position? It is a second row in third column. See, I equal to 1. I equal to 1 means it is a second row. In second row, I have to fill this position. How can I fill this? Minus 2, minus 6. Minus 2, minus 6. What is the position of minus 2? It is a third row, second column. Third row, second column means index 2, 1. See, I have written the same thing here. 2, 1. Minus 6. Minus 6 means what is the index of this minus 6? It is a second row, second column. Second row, second column means index is 1, 1. You can see index is 1, 1. We are subtracting 6 from minus 2. Okay. Next, we have to save the result in second row, third column. Second row, third column means the index is 1, 2. Once you can see here, I have written the same thing. I am saving the result in 1, 2. See that minus 8 takes this position. It is 1, 2. 1, 2 means second row, third column. Next, I have to fill this position. For that, now I takes 2 means it is a third row. We have to fill this position. Okay. To fill this position, we consider the difference minus 1 minus of minus 2. Minus 1 means it is fourth row, second column. Fourth row, second column means what is the index? 3, 1. See, you can observe the same thing here. 3, 1 minus minus 2. Minus 2 means it is third row, second column. Third row, second column means 2, 1. Index is 2, 1. You can observe that index 2, 1. Okay, now the result. What is the result here? 1. We have to save the result in this position. See, what is this position? What is this position? Third row, third column. Third row, third column means its index is 2, 2. See, we are saving the result with index 2, 2. It takes third row, third column. Look at this. Now you have to observe one thing here. Third column is completed with all differences. Okay, yes, look at this. 6 minus 3, it is 3. Minus 2 minus 6, it is minus 8. Next to minus 1 minus of minus 2, it is 1. So all the differences are completed in third column. Then we can go for the fourth column. Fourth column means what is that here? J equal to 3. Now J takes 3. Now we will see how the inner for loop works on difference table for J equal to 3. See, in this inner for loop, the range is n minus j. N minus j. N means 5, j is 3 years. So the range is 2. Means I takes 0 and 1. When I equal to 0, I equal to 0 means in fourth column, first row. Fourth column, first row means this is the position. I have to fill this position with the difference minus 8, minus 3. To get the value in this position, say I need minus 8, minus 3. Minus 8 means what is the index of this minus 8? It is in second row, third column. Second row, third column means it is 1, 2. Index is 1, 2. You can observe that. Next, 3. 3 means it is in first row, third column. First row, third column means what is the index? 0, comma 2. The index is 0, 2. Okay, now we have to save this difference in fourth column, first row. First row, fourth column. What is the index of first row? It is 0. Fourth column means index 3. Look, we are saving the difference with the index 0, 3 means it is in first row, fourth column. Here I takes 0 and 1. The next value of I is 1. Means it is the second row. See, in second row, fourth column means we have to fill this position with the difference 1 minus of minus 8. See, 1 minus of minus 8. 1 lies in third row, third column. Third row, third column means what is the index? It is 2, 2. We can see here. Next, minus of minus 8. minus 8, that is in second row, third column. Second row, third column means what is the index? 1, 2. You can observe that the index is 1, 2. And the difference 9 we have to save in second row, fourth column. Second row, fourth column means look at this. We can save here. Okay, what is the index of this? It is 1, 3. So we are saving the result with the index 1, 3 means we are saving in second row, fourth column. With this difference, the fourth column is completed. The inner for loop is completed. Now we can go for the first for loop. In this first for loop, j takes 4. Already 1, 2, 3 completed. Now j takes 4. 4 means fifth column. Okay, here j equal to 4. Now the second for loop, the range is n minus j. N minus j. What is n here? N is 5 and j is 4. So the range is 1. Means here I takes only 0. I takes only 0 means it is the first row. See in first row, fifth column. First row, fifth column means this is the position we have to fill now. We fill this position with the difference 9 minus of minus 11. Okay, with the difference of 9 minus of minus 11. You can see what is the position of 9. It is second row, fourth column. Second row, fourth column means what is the index? 1, 3. Okay, you can observe here. What is the index of that 9? 1, 3. Next to minus 11. It is in first row, fourth column. First row, fourth column means index is 0, 3. Okay, we are taking the difference of these two numbers and we are saving the result in first row, fifth column. First row, fifth column means what is the index? 0, 4. See, we can save the result with this index 0, 4. 0, 4 means we are saving the result in, you can observe here. That is in first row, fifth column. With this difference, we got complete difference table. And you can observe one thing, we got complete difference table. At the same time, if you see the first for loop, yeah, the maximum value of j is 4, that is also completed. Once we can see how the forward difference table generated here. First, we are generating a table with 5 rows and 5 columns with all zeros. Next, we are replacing first column with the values of y. Next, by using two for loops, one for loop on columns and one for loop on rows, we are finding differences in every column. So finally, we got this difference table. Now we can use all these differences in Newton's forward interpolation formula in next step. In this next part of the code, we use forward differences in Newton's forward interpolation formula and we calculate the required value. Now I will explain each and every line of this part. Now you can see already this is Newton's forward interpolation formula. You can observe here in this formula we have to substitute forward differences and the variable p. Already we have generated forward differences and p is x minus x naught by h. X means that is the target value, means x equal to 11 here. X naught means it is the initial value of x. H is the common difference of x values. We have to substitute p and forward differences in this formula. To find the value by using this formula, I have written one function here. The function name is Newton's forward, and you can observe that under this function I have to calculate few values. And finally, I substitute all these values in Newton's forward interpolation formula. See, I don't write this formula, total formula at a time. I will calculate every individual term in this formula. Finally, I will add all these terms. You can see in this definition, I am using three variables. One is x values and second one is y values. Third one is target x. Target x means at what x we need y. Okay. Now you can see under this function we need some values. First I am writing the length of x values. Okay, length of x values means number of x values. We are saving this value with variable n. Next, common difference of x values. Okay, that is saving with the h. Common difference means you can take the difference of any two consecutive x values. I am subtracting x0 from x1. Next, we have to insert the variable p. Already we know what is p here, x minus x0 by h. This is p. Okay. Next, see, already we generated forward difference table. Now we are calling that forward difference table here because we have to substitute the forward differences in Newton's forward interpolation formula. See, we are calling that for in the previous part of the code, we generated forward difference table with the name forward difference. Okay, now we are saving that forward difference table with the name difference table. Whenever I need forward differences, just I call the table with this name, difference table. Now we will see how to find the value by using Newton's interpolation formula. Okay, now we find every individual term. Okay, I don't use the entire formula at a time. See, I have written result equal to y value with index 0. Y value with index 0 means it is y naught. Okay, I am taking result equal to y naught. What is y naught here? It is the first term of Newton's forward interpolation formula. You can see here y naught is the first term in Newton's forward interpolation formula. In next step, I will update this result by adding the second term. See, by adding this second term, I can update the result in next step. After that, again adding this third term to that result, I can update. In every step, I will update the result by adding the next terms. To add the next term to result in every step, first we have to find the term, the value of the term. See, I am initiating the term with 1. The value of the term is 1. Next, I am using one simple for loop to update the term. See, what is the for loop here? I in range 1 comma n. So, what are the values of I here? I equals to 1, 2, 3, 4. So, here I takes 1, 2, 3, 4. These are the values of I. First, I takes 1. Okay. When I takes 1, then I will update the term. See, you can observe that I'm initiating the term value with 1. Now I'm updating the term by using one simple formula here. P minus I minus 1 by I. When I equal to 1, what is the result you can see? When I equals to 1, P minus I minus 1 means 1 minus 1 by 1. That is P. Okay. Next, what is the second term? P into delta y naught. Okay, I got P here. See, the term is P into here, P into, see, here I am updating the term by multiplying 1. See, initial value of term is 1. I am multiplying that 1 with P. So, P into Yes, the result is P here. Now P into, see, from difference table, I am taking the value with index 0 and 1. Okay, 0 and 1 means what is the position? First row, second column element. First row, second column element means this is first row, second column element. That is 3. Okay, already I have written what is P in the last slide. Now I will call that P value here and multiplying with the first difference value from the table. Okay, so this gives P into delta Y naught. Now we are adding this P into delta Y naught to result. Now what is the updated result? You can see here. Initially our result is Y naught. I am initiating the term with 1 when I equal to 1. Now the term is modified, it is P. Okay, next we are multiplying P with difference, first difference value from the table. Then we are adding the term to the result. Our initial result is Y naught. After adding the term, we are getting Y naught plus P delta Y naught. Okay, this is the new result value. In next step, again we update that result. Now you can observe here. The initial value of the result is Y naught. Now it is updated to Y naught plus P delta Y naught. The initial value of the term is 1. Now it is updated to P. At I equal to 1, the resultant term both are updated. Now for I equal to 2, we can see what is the term. Already we have written one simple formula to update the term here. See, we are every time we are multiplying the term with a new value. The new value is P minus I minus 1 by I. So here P minus I minus 1. I minus 1 means 2 minus 1. 1 by 2. So we are multiplying P with P minus 1 by 2. See, we are updating the term here. Next, in next step, we are updating the result value. See, the result is Y naught plus P delta Y naught. Now we are updating. We are adding the new term to the result. Okay. See, before going to add the new term to the result, we are multiplying this P minus 1 by 2 with new difference value. What is the difference value? It is indexed with 0 2. 0 2 means first row third column. First row third column. So what is that first row third column? It is delta square Y naught. Now we are adding this term to result. You can see the new value of the result. See, this is the updated value of the result. Again in next step, we updated this result by at I equal to 3. At I equal to 2, these are the updated values of resultant term. Now at I equal to 3, again we update the term and result. See, the updated term is this one at I equal to 3. We multiply this one with the next difference. What is the next difference? This one. Okay, after multiplying with the next difference, we add this term to the result. See, this is the updated result at I equal to 3. At I equal to 4, again we update the resultant term. First we update the term. See, at I equal to 4, we are multiplying previous value of the term with the new value. This is the updated value of the term. And we multiply this term with next forward difference, means this one. After multiplying with the forward difference, we add this term to the result. This is our new result. So the maximum value of I is 4, means that for loop is completed with this value. So finally we got the result with Newton's forward interpolation formula. Now we return the result to this function. In the previous part of the code, I have defined a function Newton's forward. Under this function, I calculated the required value by using Newton's forward interpolation formula. Now I am calling that function here and saving the result with the name temperature at 11 a.m. I want to see the output of my code. To see the output, I am using print function and I want to see the output with proper sentence. See, what is our question? We have to estimate the temperature at 11 a.m. That's why in my output, I have to see the total sentence, estimated temperature at 11 a.m. See, I'm writing that sentence in double quotes. To print the sentence, I have to use the double quote. Next, result. Result is saved with this name, temperature at 11 a.m. So I am using the same name here. And you have to observe one thing. I have written here round and the number 2. See, in my result, after point, I need only 2 decimal places. That's why I have mentioned here 2. We are finding the temperature. So the units of the temperature is degree Celsius. So I'm using the same thing here. So finally, this is my output for the problem. We are estimating the temperature at 11 a.m. by using Newton's forward interpolation formula. In our problem, there are two questions. First question is estimation of the temperature at 11 hours by using Newton's forward interpolation formula. Already we have calculated that value. Now the second question is estimation of temperature at 15 hours by using Newton's backward interpolation formula. To use Newton's backward interpolation formula, we need backward difference table. For that, I have defined first backward difference function, and here y is the variable I am using in these calculations. See, under this function, first I am taking the length of y. Length of y means number of y values, saving the result with n. Next, I have to generate a table with 5 rows and 5 columns. Contains all zeros. Once look at this. np dot zeros n comma n. So this generates a table with 5 rows, 5 columns, contains all zeros, and I'm saving the table with this name difference table. In next step, I have to replace the first column of the table with y values. See, we are replacing first column. Look at this. This 0 indicates the first column of the table. We are replacing that first column with y values. See, in forward difference table, we have written differences from the first row. But in backward difference table, we write the differences from last row. For that, I will do small changes in this for loop. You can observe this one. First for loop, we are using this first for loop on columns. You can see for j in range 1 comma n. So here j takes 1 comma 2 comma 3 comma 4. Here n is 5. So j takes 1 2 3 4. Next, the second for loop, it is defined on rows. If j equal to 1, now you can see second for loop, that is on rows. Okay, but we need to generate from last row, not from the first row. See, for I in range n minus 1, n minus 1 means I in range n minus 1. Here n is 5, 5 minus 1 comma j minus 1, 1 minus 1 0 comma minus 1. See here I takes 5 minus 1 means it is 4. Every time this minus 1 indicates every time we have to decrease 1 in this index. So here I takes 4, 3, 2 and the last value is 1, because up to 0 means we have to take I takes 4, 3, 2, 1. If j equal to 1, I equal to 4, 3, 2, 1. See, j equal to 1 means it is the second column. Okay, in second column in the table, in second column we are filling the values from last row. See, I equal to 4, I equal to 4 means it is a fifth row. So we are filling values from last row. Now, if j equals to 2, if j equals to 2, then what is I, what is the range here? Uh, see, range n minus 1, j minus 1, minus 1. N minus 1 means it is 5 minus 1. So I value starts from 4. J is 2. 2 minus 1. 2 minus 1 means before 1. So 3, 2. Okay, already we discussed this minus 1 indicates every time that I value decrease by 1. So here I equal to 4, 3, 2 when j equal to 2. If next, if j equal to 3, what are the I values? 4 comma 3. To find the differences, we have written one simple formula in this for loop. By using this formula, we can find the difference in every row. Now you can observe how this part of the code works. First, we are generating a table with 5 rows and 5 columns containing all zeros. Next step, we are replacing first column of the table with y values. Then, with the help of for loop, see, we are writing first for loop on columns. With the help of first for loop, we are filling the second column with differences, and we fill the second column from the last row by using the second for loop. You can observe here how we are filling from the last row. See, with the help of second for loop, we are filling the second column from last row. See, we have filled the values from last row. You can observe here. Next, at j equal to 2 means third column. Again in third column, we have to fill values from the last row. See, we are filling the values from last row. Already we discussed how I takes the values. See, you can observe that we are in third column, we are filling values from last row. Next, j equal to 3. If j equal to 3, again we fill j equal to 3 means it is the fourth column. Again we fill the values from last row. You can see here we are filling the values from last row. Okay, finally j equals to 4. When j equal to 4, this is the value we are filling. See, finally we got backward difference table. Once you can see how the table is transforming into backward difference table in every step. Initially, it contains only zeros. In every step, we are filling each column with differences from last row. So this is our final backward difference table. We use these backward differences in our Newton's backward interpolation formula. In this next part of the code, we are finding the answer by using Newton's backward interpolation formula. Let us see every step of this part. In the next part of the code, I have to use Newton's backward interpolation formula. See, I have written Newton's backward interpolation formula here. This is Newton's backward interpolation formula. Now I have to use this formula in my code. To use this formula, I need few variables here. I will find all these variables by defining one function here. You can see here, I am writing one function with the name Newton's backward. Under this function, I calculate the required value by using this Newton's backward interpolation formula. For my calculations, first I need x values, then y values and target x. Target x means what is the temperature at x equal to 15? That is the question. So target x is 15. So these are the variables I am using in my calculation. First, I am finding the length of x values. Length of x values means number of x values. Okay, we are saving the result with variable n. Next, I need h value. In Newton's backward interpolation formula, I need h. What is h here? The common difference of x values. Okay, common difference. So I can take difference of any two consecutive values. I am taking here x1 minus x0. You can take difference of any two consecutive values. Okay, we are saving the result with the name h. Next one is we are finding the value of p. See, in Newton's backward interpolation formula, in every term we can see the variable p. So what is the formula for p here? P equals to x minus xn by h. X means that is target x. Xn means lost value of x. H, it is a common difference of x values. See, we have written the same thing here in the code. P equal to target x minus I need the lost value of x. Lost value of x means look at the index what I have written here minus 1. Minus 1 means see I am writing x value with index minus 1 means here it takes lost value of x by h. Okay, we are saving the result with variable p. I need this variable in Newton's backward interpolation formula. Next, in Newton's backward interpolation formula, I need backward differences. Already we have generated a table with backward differences. See, I have written the table here. You can see already we have generated this backward difference table. From this table, I have to consider all the backward differences and finally we substitute in the formula. Okay. Now we are calling the table here. See, the table is generated with this name backward differences. Okay, we are calling the table with its name and saving the table with another name, that is difference table. We are saving that backward differences with the name difference table. See, these are the required variables to use Newton's backward interpolation formula in our code. Now we start the result with first term of the formula. You can see here y value index is minus n. Minus n means that using minus 1 as index means we are taking y values from the bottom, from the last of the table, last line of the table. See, I have to substitute these values. Okay, so I have to substitute last values of the table, bottom values of the table. Okay, now look at this. Values minus 1 means it is yn. Okay, this is the first term of the formula. You can observe the first term of the formula, that is yn. So we are starting the result with first term. Next, in every step we have to update the result by adding the next terms. See, what is our next term? P into first for backward difference. P into first backward difference. See, to include this term, see, first I am starting term with 1. See, by using one simple for loop, I have to update the term first, then I have to update the result. To update the term, we are using one simple formula here, P plus I minus 1 by I. Okay, every time we multiply the term with this value, we can generate the new value for the term. After getting the term, we add this term to the result. Before going to add this term to the result, we have to multiply the term with backward differences. Okay, and you have to observe one thing here. The most important thing, we are using values from bottom of the table. See, index I am writing minus 1. So we are using values from bottom of the table. That's why we are writing index minus 1. Okay, you can see here starting value of result is yn, and the starting we initiated the term with 1. For I equals to 1, we are updating the term. Look, initially it is 1, and we are multiplying that one with a new value. We are multiplying that one with a new value here, and this is the new term. And we are multiplying this new term with backward difference. You can observe here, we are multiplying with backward difference. Then we are adding this term to yn. So this is the updated result. Now you can see at I equal to 1, we updated the result and term. These are the updated values. Now at I equal to 2, again we are updating the term and the result. We have to continue this process. See, at I equal to 3, we are updating the term, then we are updating the result. Finally, see, at I equal to 4, we are updating the term and the result. With this, we got complete Newton's backward interpolation formula here. So that calculates the required value. Now I want to see the output of this part of the code. See, what is our question? We are calculating the temperature at 15 hours, means at 3 p.m. Now we are calling the function Newton's backward. This is defined in the previous step. Okay, this function calculates the value by using, calculates the answer by using Newton's backward interpolation formula. Okay, that's why we are calling that function here and saving the result with this name, temperature at 3 p.m. Now I want to see the output with proper sentence. So by using print function, see in double quotes I have written estimated temperature at 3 p.m. because in my output I have to see this sentence. Next, result is saved with this name, so I have to use this variable here, and you can observe round to means after point I need only two decimal places. So this is the final output of the second part of the code. We are estimating the temperature at 3 p.m.